All right, excellent problem here with the rocket. We're first tasked with figuring out the maximum speed of the rocket. Given the thrust of that engine, the amount that the engine is pushing up on that rocket, and the weight of the rocket, we can figure out that acceleration of 27.5 meters per second squared using Newton's second law. I just looked at how the forces were unbalanced vertically, divided by the mass, 0.8 kilograms, of that rocket, and got the acceleration. This purple part here is the rocket taking off, accelerating upward. And I set up a table to look at the vertical displacement, initial velocity, final velocity, acceleration, and time that the rocket is moving. And figured out that if I know the amount of time, the initial velocity, and the acceleration, I can get that final velocity, and that's the maximum speed of the rocket, happens right there. The rocket keeps traveling upwards, however, and keeps going up, all while gravity is pulling it down. Once this thrust goes away, the only acceleration is due to gravity. The rocket keeps going up, and I figured that happens for another 605 meters after it reaches its maximum speed. So the actual maximum height above the starting point ends up being 825 meters. Then the rocket descends, accelerating because the parachute only applies 7 newtons of force, while the weight of the rocket is 8 newtons. I figured that acceleration was 1.25 meters per second squared down. I switched down to be called positive here. And then figured out that that's going to happen for 12 seconds until the rocket reaches a velocity of 15 meters per second down. From that point, it's going to continue the rest of the 645 meters because it travels 180 meters while the parachute is only at 7 newtons. But then, once the parachute's at 8 newtons, this rocket has a constant velocity, balanced forces, and travels down 15 meters per second. Which means it is launched for 4 seconds, travels another 11 seconds upward as gravity pulls it down and slows it down. Then, the parachute deploys at its highest point. It accelerates for 12 seconds and travels at a constant velocity for another 43 seconds for a total of 70 seconds on the way down.